In our last class, we have seen about module parameters. How can we pass parameters to modules? Today we'll be looking into more examples of kernel modules. So did anyone try writing a module code without specifying module underscore license? So did anyone try that? So am I audible?
Yes.
There are some problems here. I'm in hometown, so there's some problems here. Internet activity. So this was the question, like what happens if I don't write module underscore license? Will the KO will be generated?
Yeah. It will throw a warning in during build and it will load successfully. And the mod info doesn't show the license information.
Oh, yes, perfect. So it is throwing a warning in the module post stage saying missing module underscore license. So, and the KO is generated. Let's see mod info then. So mod info does not have information about the license here or about loading this module. So I'm loading this module. So it failed. It says module license unspecified. So first of all, it is an out of tree module. So this is a common error. It contains kernel. And then it's saying module license unspecified. So it is, as we have not specified any module license, it's saying module license unspecified. But the module has loaded and the print did work. So what is this taints kernel means? What does this mean? So what is a tainted kernel? So when the kernel is tainted, it means it is in a state which is not supported by the Linux community, the kernel community. So whenever it is in a tainted state, this means the community cannot support you to debug the issue. So whenever and debugging functionality and API calls may be disabled when the kernel is tainted. So what are the cases where the kernel may be tainted? So these are the few cases. One of them is if you are loading a non-GPL compatible kernel module. Example of them are NVIDIA, AMD video drivers. If you are using a staging drivers, so staging drivers are part of the kernel source code which are not fully tested. If we are using out of tree modules, so we are using out of tree modules, so the kernel will be tainted. And whenever there are oops message or machine check exceptions, the kernel will be tainted. So kernel is tainted means it is a state which is not supported by the community. So how can I check the tainted state? I can check a proc file to verify whether my kernel is in a tainted state or not. So one more thing is now you can see it has said loading out of tree module license unspecified and all those. So what happens if I load again? Will I get this all messages again? So I have removed the module. So will I get these messages again if I load the module again? So you can see those messages are not again present in the kernel buffer. So these messages will only be printed once. Once the kernel is tented, it will not again print tents kernel. So once for the first time it is tainted, it's over. It will not print for you that it is tainted again. So how can I check whether my kernel is tainted or not? Suppose someone has cleared my kernel buffer. So how can I know whether my kernel is in a tainted state or not? So there is a file. So there is a file proc sys kernel tainted. So this will return 0 if the kernel is not tainted. Any other number means the kernel is tainted. Let's see this file. So it is a value is not 0. The value is greater than 0. This means kernel is tainted. So what is the meaning of this value? How can I understand what is 12289? So kernel has provided a script known as kernel check taint. So this script is present in the kernel source code. You can download this script directly from this link. So it is present in tools, debugging, kernel check taint. So I have downloaded the script. So I have this script here. So this is the script. So I can just say kernel check taint. And it says kernel is tainted for the following reasons. So it gives the reasons. These are the reasons by which the kernel has tainted. And it also convert the int into a string, POE. So this is the number which we have seen in the file. So it converts it into a string. These are the flags. P is a flag, O is a flag, and you can understand these flags from this link. As we have loaded a out of tree module, the kernel was tainted. So this POE can be understood from the flags. So P means any proprietary module has been loaded. So we have not specified modules without a module underscore license is assumed to be a proprietary. You can see here P means modules which do not have module underscore license is known as proprietary. So we have seen P. Then we have seen O. O means out of tree module has been loaded. E means unsigned module has been loaded in a kernel supporting module signature. So this is a number is converted. This number is actually this. So each and every has a macro. They convert this flags into a number. That number we can see from this file. So let me restart. So then we can see whether the value of this file is 0 or not. So you have any questions here?
Is there a way to find which module is currently tainted or?
As of now, I don't know any way where we can check like which is the module causing the tainted. So one of them is if the D message is there, the kernel buffer is there, you can check that kernel buffer. But if the kernel buffer is cleared, there is no such a way where we can see which module has caused tainted. We can check ls mod and then look into modules which are like out of tree modules, and then you can verify.
Right.
So virtual machine is busy. So we can now check the status proc sys, or what is it? Let's see again history. Cat proc sys. So the value is 0. 0 means the kernel is not tainted. And also run this check taint. So it says kernel not tainted. So this was one of the question, right? What happens if we give some arbitrary string module license? Like we don't say GPL, we say something like ABC. What happens when you say ABC or some other thing which is not a license? So suppose if I say ABC here, with the module, what do you mean? Like when you say ABC, what do you think? The kernel will be tainted or not? What is the output of mod info? It will be ABC. GPL will license will show ABC because it is just writing to a mod info section. So it will not check whether the license is correct or not. But the problem happens when we load the module. So it's saying module license ABC taints kernel. Okay, now we can check the state again. So we have the same value. So it's the same if you write module license, arbitrary string the module license, or if you don't write, you can see the output is almost same. This is a previous code which we have seen where we are exporting a symbol. Symbol here is function my add. This is a GPL symbol. Okay. And I'm trying to access this symbol my add, but my license is proprietary. So it is not a GPL license, it's a non-GPL license. So can I access this? So can I access this from this code? Previously, this was a GPL license, so I can access it. But here I have a non-GPL license.
No, we cannot access it.
So we cannot access this. Let's try. So where do you think the warning or error message may come? What stage? After loading the module or before loading the module? So let's say make. So it's giving a warning before actually building the queue. So you can see in the mod post stage, it's saying GPL incompatible module uses GPL only symbol. So the warning happens before the queue is generated. So and the make file is failed to generate a KO for the second module, also as well as the first module. So is this clear? So only the GPL compatible modules can use GPL only symbols. So if you don't use module underscore license GPL, you cannot use the symbols exported by GPL symbols exported by modules. So what you can get more detailed information what is happening when you do make using make b equals to 1. So let's do make clean. Now we can say make b equals to 1. This means you're setting the verbose for make. So you can see what is happening internally. So what all commands are being run by make. So it is running mkdir first. So it is creating .temp versions. Then it is running make. So all those it is doing here. So you can do check what is happening internally by using passing v equals to 1 to make. So here it is, you can see from here, it is looking into the module.symbols file. As the, you know what this file contains, we have seen, right? Module.symbols file contains what? Can anyone guess what is the use of module.symbols? The name is suggesting it. We know modules.order, right? Modules.order is if you have multiple modules, which module got generated first. What about symbols? So SSN2. Let's say, comment this out. Now we have a module.symbols file. So now you can guess what is the use case of this file. What information it contains? It contains all the symbols exported by the module. So in our case, we are exporting my add function. So that information is present in module.symbols file. So module.symbols, sim stands for symbols. Symbols, all the symbols related information is present in module.symbols file. So how to find the version of a compiled kernel module? So you have given a KO by a third-party vendor. So you have a hardware of third-party company. They gave you a KO file. How can you check what is the kernel version of this? Like which kernel it was built for? So you can use modinfo to check for which kernel version the particular KO was generated. Like we can say modinfo. It will give you the version magic, right? Using the version magic, you can find out which is the kernel version for which this KO was generated. So if you don't have the kernel version, you can just use the modinfo tool to find out the kernel version. So we have something known as module metadata. So you can add metadata to the module. So you have macros like module underscore description. Using module underscore description, you can add a short synopsis of what your module is actually doing. You can add a module author. You can add a module version. So in this code, so I have added module description, module author, module version. So I can check all those information using modinfo tool. So you can see the version which we have added. License author is present here. Description is also present here. So these are the one which we have added. What about the remaining? The source version. What is this red Pauline? We know what is word magic, right? Word magic is the one which we compare, if the kernel compares before loading the KO. So what are the remaining? Let's see. So how many of you know about Spectre bug? There was a bug which was Spectre bug, which like Intel has to release a patch for that.
I know it.
Yeah. So that solution for the Spectre bug was Red Pauline. So Red Pauline was a solution to avoid the risk of Spectre bug. So if you see in your mod info, Red Pauline is Y. This means the configuration for Spectre bug solution is enabled. So solution for the Spectre bug is enabled. If you see, Red Pauline is Y. Then you have var magic. Var magic means it will check whenever you're loading a module, the string in the var magic should match with the kernel var magic string. If they don't match, the kernel will not load your module. And you have one more thing known as entry. This is not present here. So this is not present here. So, but this will be present for the entry modules. So let's say if I do mod info on E1000, which is, you can see there is a entry. This means it is a part of the kernel source code. Out of tree module means it is not part of the kernel source code. As our module was out of tree, it is not showing it. Then we have source version. So source version is a MD4 hash of the source code, which is used to compile the kernel module. So it is generated by the modpost script. So why do you think this is needed, source version? Can anyone guess what is the use case of this? What is the use case of a hash? This is a hash of the KO, of the code. So let's assume a scenario. You have given a KO to your client and there is a bug in the KO. Your client has reported the bug. Now you have found the solution, you have generated a new KO and you have given this KO to your client. And the client is coming back saying the bug is not resolved. But you know, you are sure that you have resolved the bug. This means there is a chance that the client has not loaded the solution KO. How can you verify which is the KO which is present in the, which is loaded by the client? Just say mod info hello.ko, and this is a hash. This means this is unique for each and every KO. If he reports with the value of the older module, you can say that you have not loaded a solution of the KO file. Since you have not loaded a new KO. Is this clear? So this is useful when you have not added version tag. So if you have added a version tag, you can directly ask for version tag. But if you have missed adding version tag, you can just look into source version to verify whether the client has loaded the new KO or not. So we know this all module underscore description, they are macros. So they should be defined in some kernel file. So let's go into the kernel source code. So this is the latest kernel source code which I have downloaded. So we know we have macros known as module underscore version. Let's grep for module underscore version. So we can see module underscore version is calling module underscore info. So it is hash defined to module underscore info. Let's search for module author. So module underscore author is also calling module underscore info. And it is present in the Linux module.h. Hence we include this file. Let's look for module license. So this is also calling module underscore info. So let's open grep, open the file and look for module underscore info. So you can see module underscore info is calling again underscore module info, and this go on. This is present in some other header file. So what it means is all this are calling internally module underscore info, and this has the form of tag equals to info. So I can directly use module underscore info if I want to add my own information. So if I want to add my own information in my KO file, I can directly use mod info directly. So I say here module underscore info is, I can set set the name to tag. This is the tag, this is the value. Name to embedded and OS to Linux. So instead of, so as I don't have any module underscore OS, module underscore name, I can use module underscore info to add generic information. So now as I make, I can use mod info. So you can see OS is Linux, name is embedded. So you can use mod underscore info for this. So we know that our module is a ELF file. The ELF is executable linkable format. So we can use objdump to check all the sections, like what all sections are present. So some of the sections, like the text section, will contain the executable code. So to see all the sections, we can say objdump -- check section headers. This will give us what all sections are present. So let's do it. You can see we have text section. We have also mod info section here. So if I want to see the contents of mod info section, I can just say, I specify the section is mod info, and I say show me the full contents of it. Then you can see it shows the full contents, and this is the information which is present in mod info. License dot is GPL, it is dot is there. So dot is a delimiter here. So you can see all the information which is present here is displayed by mod info utility. So mod info actually reads the mod info section in the KO file, and it will display you the information. Any queries still here? So what happens if we continuously call print k? We know the print k is writing to a kernel buffer, and this buffer should be of a particular size, and d message is just printing the contents of the buffer. So what happens if we say, like, if we continuously call print k? So here in this code, I'm calling a function known as func from my init function, and this is calling print k 50,000 times. So what do you think will happen to the print k of the kernel buffer?
So since it's a circular buffer, it will like
overwrite the existing content.
Yeah. Yes.
We have the existing contents starting from the command line, from the how the kernel is booted. So let's run this code. We can see the existing contents have been overwritten by the newer contents. So as it is a circular buffer, the existing contents will be overwritten. So how can I find out what is the size of my kernel buffer, the circular buffer used by the kernel print k? So print k is implemented by using a ring buffer, circular buffer. which is having a size of like log underscore buff length bytes. And this is assigned to the config log buff shift. So this is the value to which it is assigned. So it will be like left shifted this many times. So we can see what is the value which is present in our current kernel config. So just look for the config log buff shift. So its value is 18. This means 1 left shift by 18, which is 2 power 18 is the buffer size. And if you grep in the kernel source code, you can find how is this used. There's a print k kernel print k folder in the print kernel source codes. You have printk.c file which is implementing all the printk command, printk function. So if I search for this file, this config option, you will be finding it. So you can see it is as defined to this. So underscore log buff length is nothing but 1 left shift by config, and this log buff length is used in a buffer. So they have a static buffer of size this. So how can I change this buffer? So one option is when you're compiling your kernel, you can change the buffer by using the configuration option. Like you go into general setup and you say kernel log buffer size, and you can specify the maximum size like what you want. But this needs to recompile your kernel. There's one more option where we can increase the buffer size using the kernel command line. So there's a kernel command line option where you set this value log underscore buff length equals to 4m. This will make the buffer size to 4m. So this means you have to update the bootloader options. So you go to your, like we are using grep here. So if I can update my kernel command line to this, the kernel buffer length will be set to 4 megabytes. So there are two ways by which we can change the kernel log buffer size. The first one is using the menu config, and you have to recompile the kernel. And the second option, you can just update your kernel command line. So there is no need of recompiling the kernel. Is this clear? So can I load any file using insmod? So I create hello.ko using touch command and make it executable. Now it is hello.ko. Can I load this using insmod? So can I check this using, let's say empty something is not a ELF file. So can I use insmod to load this file?
Actually, we can't, I guess, because it needs some module version things and those.
That's what
Depends.
module info is doing here. So it could not get mod info from hello. It's saying invalid argument. Okay, let's do insmod. So it says could not insert module invalid argument. So it is directly giving the invalid parameters. So what happens when I say insmod on the KO? What are the steps? So insmod is a user space utility, and the KO is loaded in the kernel space. So what are the steps which happens when I say insmod? So what happens when we do insmod on a module? We know what is a kernel module. Kernel module is a piece of kernel code which can be added to the running kernel when loaded and can be removed from the kernel when the functionality is removed. So what happens is first the kernel will call init underscore module function. So init underscore module function is a system call. We already know, we should know what is a system call there. So init underscore module is a system call which is used by INSMod to inform the kernel that a module is being loaded, and then the kernel and the control is transferred to the kernel space. So from the user space, a init underscore module system call is called. That transfers the control to the kernel space. In the kernel space, this function is called sys underscore init module. This function will perform a sequence of operations. Like it will verify the user who is attempting to load the module, whether he has a permissions or not. Like if I try to load the module without a root user, without doing sudo, this is the check which happens in the first stage. After verification, like now I am a root user, a function known as load underscore module is called. This function assigns temporary memory, and then it copies the ELF module from the user space to the kernel space using copy from user kernel function. The copy from user will copy the code to this temporary memory. Then it will check whether this is an ELF file or not. If it is an ELF file, then it will do some option. It generates offset, and all the user arguments are also copied to the kernel memory. So user arguments are also from the user space. They are also copied to the kernel memory. Symbol resolution is done. Like if you are using any symbols exported by the kernel, so that resolution is done, and the load underscore module will return a reference to the kernel module. This reference is added to a doubly linked list, which has list of all the modules in the system. So when you do cat proc modules, right, it will actually print the contents of the doubly linked list. Then the module underscore init function, and the module is called. So this is what happens when you load a module. First, the sys init underscore module system call is called. In the kernel, it calls sys underscore init module. Then it performs a lot of steps. First, it checks for permission. Then it will check whether it is an ELF file or not. It copies the ELF file into the kernel space, performs symbol resolution, adds this into a doubly linked list of modules, and then finally our init function is called. You can verify this using strace command. So I say, go back here, I say strace -o. I write the output of strace. So this is a lot of thing. So this has a lot of kernel buffers. Let's use a simple queue. So this is a simple code. So I say strace, write my strace output to temp strace.txt, and I have to be sudo first. So sudo -s strace and load the module. This is the command for strace. It already is there. So let's see what is the content of temp strace. So it calls execv and a lot of memory maps. Finally, you can see it should call. It is calling a function known as f init module. So it is opening the ko, hello.ko, and calling a function known as, it is not a function, it is a system called f init module. So we said init module, right? So there is one more f init module. You can see it is a system call. You can see from the section in which it is a system call. So we have two system calls to load a module, init underscore module and f init underscore module. So INSMod is using f init underscore module. So f init module needs the file descriptor. So hence it calls open on the KO. It gets a file descriptor, and that file descriptor is passed using here. And any parameter values you pass will be here. So f init module is the system call used to load the module. Any questions here? We have seen what happens when INS mode is called. So how can I find out what is the name of my module from my KO, from my module code? So I can get it by using kbuild_mod name. So there is something known as kbuild_mod name. So this contains the name of my module. So I'm getting this, I'm calling stringify to convert into a string, and I'm printing that module name here. So this is useful when you have a different module name and .c file is different. So make clean, make. So you can see module name loaded. This was our module name, right? Module name removed. So I can verify this. How? So how? Where is this particular mod kbuild mod name? Who is setting this? This is set by the kbuild kernel build. So if you do make v equals to 1, verbose make, and grep for kbuild_mod name, you will be finding that it is defining a variable kbuild_mod name with the string mod name_test. So this is how the kernel, this is being performed by the kernel build. So this is being passed to the GCC also. So if you, this is a function, kernel function provided called as dump_stack. This will make a stack trace to be printed wherever you're calling this particular function. So in this, I have dump_stack being called in my init function. So let's see what happens here. So you can see a call stack is being printed here. You can see the message. Yes. So dump stack, this was first print k, and then you can see a call stack is there. It is printing the CPU number where this executed, the PID of the NSMod process, and it has tainted because it is out of tree module. What is the hardware name? I'm using a VMware, so this hardware is VMware. This is the call trace. So we have done INSMod called finit module system call, and it came in the kernel space. So this was a system call entry in the kernel space. And it called sys finit module. This is the implementation of the system call, and we know it calls load module. We have seen, right? It calls load module, and finally our init function got executed, and then we call dump stack, so that is printed here. It also prints the contents of the CPU registers, whatever CPU registers are there. So call dump_stack will print the call trace, and it will also print the contents of the CPU registers. So have anyone seen what is when they are like, what is a kernel panic? Like anyone while working with Linux have seen this kernel panic?
Yeah.
Yeah, most of you.
One of the crash.
Whenever you are what?
Segmentation fault.
So that is a segmentation fault is when you're working with user space applications. So if you happen the same, like if you're trying to access null pointer, the same thing happens in the kernel space. This we call as kernel panic. So kernel panic is an error in the kernel code. It is an error in the kernel code. What happens on kernel panic? Kernel will stop running immediately to avoid any data loss, any other damage, because kernel is the one which is controlling your computer. So to protect your computer, the kernel stops. This is like, for example, if you're having a module which is controlling the fan, if it fails to load, kernel will generate a panic and it will freeze the system. So what are the reasons for kernel panic? So if it is unable to start the init process is the first process which will be loaded. Bug in the kernel driver. If there is any bug in the kernel driver, or if you have some defective or incompatible RAM. So these are the reasons for kernel panic. So what happens during kernel panic? When the kernel decides to panic, it calls the panic function. The panic function will dump debug information, and depending on the configuration, it reboots the system. So there's a configuration which you need to do. Depending on this configuration, it will either reboot the system or it will stop. It will not reboot the system. So the main important thing is it will call a function known as panic, and this panic function will dump some debug information. So how can I configure my kernel to reboot on kernel panic? By default, the kernel will not reboot on kernel panic. You have to instruct the kernel to reboot. So there are different ways. So you have to use, one way is using the kernel command line. If you say panic equals to n, so this will instruct the kernel to reboot after the n seconds. The other way is to use the proc file system. So how can I check the kernel command line? What is the command line by which my kernel is booted? How can I check after my kernel is loaded? I want to check the kernel command line now. So you know how to check what is the kernel command line? We have different ways, right? One option is dmessage. So if you see the dmessage, initially first log, you will be having the kernel command line printed there. The other option is cat/proc command line. So using this, you can also find what is the command line by which your kernel is printed, with which it is booted. You can print using proc command line. So if you add panic equals to n to this will make the kernel to reboot after n seconds whenever there is a kernel panic. The other option is updating this. Proc is this. The problem with this approach is it will be erased on the next reboot. So again, each time you have to do it, you have to update this file. So you can check the status of this now. Say, what is the content of this? Initially it is 0. This means it will not restart on panic. So I can say echo 5 says permission denied. Let's give sudo. First become a sudo user, and then run this command and verify the content. So we are saying after panic, restart my system after 5 seconds. So in my code, I'm calling a function panic. This is the function which kernel uses whenever it wants to panic. And I'm passing this hello kernel, I'm causing the panic. Okay, let's see what happens. Will my system restart? So you can see it has restarted. So the VMware, it may have restarted it earlier, but on your normal machines where you're not using any VMware, it will dump a message and it will restart after 5 seconds because we have given 5 seconds as the delay before actually restarting. So whenever the kernel panic happens, your system will be restarted depending on what you have set the panic option. You can try on your normal machines where you're not running VMware, and you should find it will restart after like 5 seconds. Now you can check the content of that file. It will be 0 because proc files are not persistent. Those are not persistent in a reboot. The best option is to update the kernel command line. So you can now check proc sys kernel panic. It will be 0 because these are not persistent across reboot. So loading the module will either freeze or reboot the kernel depending on the kernel configuration. So we have one more, like we have seen panic, there is something known as oops. So what is the difference between the panic and oops? So oops is similar to sec fault in user space. So kernel will throw an oops message whenever it sees an exception, like it is accessing invalid memory location in the kernel code. What happens on oops? The process which is trying to perform oops, the who's doing the oops will be killed by the kernel. It will print information which can help the developers to debug, and it will continue execution. Whereas in case of kernel panic, execution is freezed. System is freezed. We cannot continue execution. But in case of oops, we can continue execution. But the important point is system cannot be trusted further because some of the logs may not be, or structures may not be cleaned up. So the difference between oops and kernel panic is, in case of oops, the execution continues, whereas in case of kernel panic, the execution is stopped and the kernel is freezed. An oops message will contain this information: the processor status, CPU registers, whenever the exception has happened, stack trace, call trace. So in this case, we are trying to access invalid memory location. So we are trying to directly access a physical virtual address 12, which we don't have permissions. We're trying to write A here. Let's see what happens in this case. So this is the code. So I have not having a module license information. It's okay, let's not have module license there. Let's clear the kernel buffer. Now let's load this module. So as I said, what is the first thing that happens when a oops happens? It kills the offending process. You can see it's shown killed. Then it will print the information which is helpful for the developers to debug. And then it continues execution. Let 2D message. You can see it is printing the information. So this information contains, so you can see it is saying unable to handle null pointer dereference at this. So this is the address which we gave in the code and it failed. And it prints the oops. And the CPU, which CPU it was running the PID hardware. And as I said, the contents of the CPU registers are being printed. Call trace is there, as well as, again, the CPU registers are here. So you can see which you can also find out what is the line which is causing the oops message. So in the debugging session, we'll be seeing how can I use GDB to find out the line using these addresses which it is printing. So it prints an addresses here, the code segment addresses. So using this, we can find out the actual line which is causing the oops message using GDB. So in the debugging session, how to debug kernel, we'll be looking into using GDB to find out this information. So you can see the kernel is now, I am still able to continue my operation, but in case of panic, that will not happen. So one more is bug. So this is the most found macro in the device driver code. So bug on or bug. So if I can just grep for in the Linux source code. So grep for bug. So you can find out a lot of bugs are there. You can say bug on. So a lot of bug on are being used in the Linux kernel. So what is this macro bug on? Why should we use this macro? Why are this used so frequently in the Linux kernel source code? So let's do a count of how many times this is used in the kernel. Okay, let it complete its execution. So bug on condition. So this are the ways. You can either give a condition in the bug on, or you can use if condition and then you can give bug. So if you grep for this, you will get 5,000, more than 5,000 count. It's still running. So bug macro, what it does, it prints the contents of the register, prints the stack trace, and the current process is tied. This one more macro known as warn on. This will print the contents of the register. It will print the stack trace, but the current process will not be killed. So you can see bug on is used almost more than 13,000 times in the kernel source code. So an example again, where we can show like, if I say bug, this particular process will be killed. So this means this line should not be executed, and somehow this line got executed. If you can use this when you're developing your code where you have incomplete code and you can add bug there. So you can know like this is an incomplete code. So it's a segmentation fault code dump, and it will print the registers. It gives a line number also. So cat -n bug test.c. Line number 8 is where we have seen the bug. So we are running out of time. And one more important point is I cannot remove the modules whenever I have a oops or bug. So if I try to remove this module bug test, it says it is in use. So because it is not successfully loaded, we cannot remove this module now. So I have used something known as conditional compilation here. Like I have defined a debug flag, and I'm only trying if my debug flag is enabled, I will print this. If my debug flag is enabled, I will print this. So what do you think? Like how can I pass this debug flag to my make file? How do you do it in your GCC? If I want to pass a debug flag to GCC, what do you do? In your C code, you want to, while compiling, you have to enable the debug option. Has anyone tried that, like passing GCC options, like enabling any pre-processing commands?
-d is used.
-d, yeah, -d is for define, and then you pass the name which you want to define. So when you say -d define, this will be successful, and this particular line will be printed. Now in this case, how can I do it is, so I have this thing, make file. So you can see this make file, I'm saying I have to say C flags. Whatever C flags you want to pass, you have to use C flag. This debug is one of the flag. So this you have to keep in this following syntax: C flags underscore module name dot o for a particular C file. So we have hello.c. If you have hello.c, you say C flags underscore hello.o underscore debug. But if you want to give it to all the C files used by the module source code, then directly say cc flags-y. This will be assigned debug to all the C files. So now in this, we have only used one C file, so I'm using this option. Now I say make. So let's say sudo make new. I have used. Let's say append. Just a second. Give me a second. Just give me 5 minutes and I have one more to look at. So this module is exporting my add function. This module is exporting my add function. This is present in a different folder, and in my another folder I'm using that function. So will this work? Let's see, will this work or not? I say make. There's some problem with the make file now. So don't ever try to use root user to write your code. Always write your code in a normal user and then only compile it by using sudo command. Okay, we have make. So it is saying my add symbols undefined, but we know we have my add symbols in this particular file. So how can I tell my this particular make file that I have a my add symbol, but it is not present in my current folder, it is present in the another folder. This is the folder. So I can using kbuild underscore extra symbols. If I use kbuild underscore extra symbols, I can inform the make file to look for the external symbols in the other file. So this, you have a symbol in another external module and you want to use this. Kbuild needs to have the full knowledge of all the symbols. If it does not have the knowledge, it will fail with, it will give a warning undefined symbol. So whenever an external module is built, this file is generated. It contains all the exported symbols which are not defined in the kernel. If I provide kbuild underscore extra underscore symbol with the location of this file, then that will work. So what I have to do is I have to give the path of module symbols here. So here we have given this path. So we have my add present there. So let's move this make file. Say make. Now you can see there's no warning there regarding the my add. And now you have to load your first module first, then this module. If I have hello first, let's see no hello. Don't have hello. So it worked. So we have to use kbuild underscore extra symbols if I'm using a symbol exported by another kernel module and this is not present in my current folder. If it is present in some other folder, I have to give the whole path. Okay, let's stop it here. Let's stop it here. We have covered a lot. Let's revise whatever we have covered. Can I load my kernel module without module license?
Yes.
Yes.
Zero.
0.
All of above.